Evaluate the range of a plus b, where a, b are positive, satisfying a minus 1 over b plus b minus 1 over a plus 1 equals 0. Since a minus 1 over b plus b minus 1 over a plus 1 equals 0, so we can write a squared minus a plus b squared minus b plus ab over ab equals 0 by finding a common denominator of the three terms on the left-hand side of the equation. Now we rearrange the equation. AB times 0 is 0, so we can now write a squared minus a plus b squared minus b plus ab equals 0. We rearrange the equation by writing the quadratic terms as one group and the linear terms as one group. So we have a squared plus b squared minus a plus b plus ab equals 0. We know that a squared plus b squared plus 2ab can be written as a plus b all squared. So to write a plus b all squared, we also write a minus 2ab. So the equation is now a plus b all squared minus 2ab minus a plus b plus ab equals 0. Now we simplify the equation, so we have a plus b all squared minus a plus b minus ab equals 0. By rearranging the equation, we have a plus b all squared minus a plus b equals ab. Since a minus b all squared is greater than or equal to 0, so by adding 4ab on both sides of the inequality, the inequality still holds true. By expanding the perfect square a minus b all squared, we have a squared minus 2ab plus b squared. So the inequality is now a squared minus 2ab plus b squared plus 4ab is greater than or equal to 4ab. We can simplify the inequality. Minus 2ab plus 4ab is 2ab. So the left-hand side of the inequality is a squared plus b squared plus 2ab, which can be written as a perfect square, a plus b all squared So we have a plus b all squared is greater than or equal to 4ab. By rearranging the inequality, we have ab is less than or equal to a plus b all squared over 4. Substitute inequality 2 in equation 1. We have a plus b all squared minus a plus b is less than or equal to a plus b all squared over 4. Divide both sides of the inequality by a plus b all squared. We have 1 minus 1 over a plus b is less than or equal to a quarter. By rearranging this inequality, we have 1 over a plus b is greater than or equal to 3/4. By rearranging the inequality, we have a plus b is less than or equal to 4/3. From equation 1, we have a plus b times a plus b minus 1 equals ab. Since a, b are greater than 0, so a plus b must be greater than 0. ab must be greater than 0. From equation 4, we know that a plus b minus 1 is greater than 0. By rearranging the inequality, we have a plus b is greater than 1. From inequalities 3 and 5, we know that 1 is less than a plus b is less than or equal to 4/3. Thank you for watching. Hope you found this video helpful. Please subscribe to this YouTube channel for notification of new videos. See you next time.